So let's go back to the notes on Friday really quick, because some people weren't here. But in short, we did the parallel line proportionality theorem. I got it. All right, that said, basically if I have parallel lines, if I have a triangle and I have two parallel lines cutting through it, then I can compare A to C the same way I can compare B to D. In other words, their ratios are the exact same. Just like I could do A to B and C to D. Where this fell apart is when I tried to compare segments to our parallel lengths. So I couldn't say A to C, that's just a segment, to another segment is the same thing as these parallel lines. That does not work. So when I go back to that the example for today, we see that I'm comparing R to S. So we find R to S. Well, R is one of my parallel lines, S is my other. In other words, they're bases of these triangles, right? They're comparing R to S to A to B. Well, A and B are segments. You can't do this segment property when you're dealing with our parallels. So in fact, this first proportion is false. In order to compare those diagonals, you have to use a whole side somewhere in there. All right, it has to be a whole. You can't do segment to segment and then compare to a whole and a whole. All right, you can do segment to segment, segment to segment. That makes sense. But segment to segment, whole to whole, does not work out. In our next one, we have J to A. So that's a whole side, right? I have a whole side compared to that. And that's comparing to my parallel to a parallel. That one is okay. That one is true. This one is true because I'm holding that. I'm holding onto the actual triangle ratios. All right. This is a whole big triangle, right? You see that? And this A here is a small triangle. So I'm comparing that big triangle to the small triangle. Same thing with this is part of my small triangle to my big triangle. Right? Because they're both big to small triangles. Do you see that? Oh, yeah. Just go with me right there. That I'm comparing the big to the small. This one over here was R to S, which was a whole part of my small triangle and a whole part of my big triangle. And it was saying it's the same thing as A to B. Well, A is the whole part of this triangle, but is B the whole side of the big triangle? No, it's just a segment. So if you just have a segment like this, if I'm not doing the whole triangle, yeah, I can compare it to this segment, but I can't compare it to our parallel lines because those are whole parts of that triangle. Okay, so I'm basically comparing a whole of that small one compared to the whole of the big one compared to the whole of that small one. That's a segment of the big one, just part of it. This is only part of it. That does not work. So whenever I'm dealing with my parallel lines, it always has to be a whole side. At some point, you have to use that whole side. You can't use this little segment here. Okay? Does that make sense? I know we went over that on Friday, but it can kind of go over the weekend. Okay, is that making sense? Okay. I do want to really quick, before I completely forget, and then I don't actually get to it, go ahead and look at that review I made for you guys. I want to make one small adjustment to it. Let me take a picture of it really quick. It's on problem number 1. And if you'd start this, you'd be like, well, that doesn't make sense. So these are two similar shapes. All right, we're supposed to find all the angles and the missing sides and whatnot. It's just a review I handed out today. Yeah, I think. I can't really see, honestly. I just see you pointing. I'm like, yeah, maybe. If it looks like this, then yeah. Okay, here's the problem. I said they're similar, and it makes sense because I have 20 to 14, so this one's obviously smaller. The problem comes in here because this one's 11, and this one's 11, which means that's, wait, it can't be that.
I was looking at
Yeah, he was looking at that. This is kind of a joke. It's like this is smaller, but somehow this is the same size. So what I want you to do, that 11 was just erroneously put there. Go ahead and just scribble out that 11. We actually don't know that length.
What does that word mean?
Erroneous? It just means there's an error. I did it in error.
Does it both start with
I think just scribble out both of them.
No. This 11 needs to be here.
Oh, okay.
Because you're going to use this 11 to get this missing blank. Brian just crossed out the whole drawing. Done.
Like the
No, I got you. Yeah. Nope. Just this 11 gets crossed out, and then you're good. All right, so that's going to tell you you need to find this side.
Does this have decimals?
This will have decimals, yes. Okay, but I'm going to finish. Today's lesson is going to go really, really quick. That'll give us plenty of time to start the homework. And I'm going to go over that in a second and what order I want you to kind of do it in. All right, angle bisector proportionality theorem. The angle bisector of a triangle divides the opposite side of the triangle in proportion with the sides with the sides adjacent to the bisected angle. So basically this, as long as it's an angle bisector, right? We have two equal angles. This creates brand new ratios. Particularly, I can say that the ratio from A to N is the exact same thing as B to G. Another way I could say that is I could also say, well, A to B is equal to N to G. And for this to work, all we need is an angle bisector. Okay, so be on the lookout for problems that have angle bisectors, because this is what we're going to do to solve them. Yes, Madison?
So when you're, I got like the A and the B, but when you're saying like A over B equals N over G,
Mm-hmm.
you always pick the one, if it corresponds with A, you pick the one closest to A.
Yep, from the same triangle. So if I'm doing, are you talking about the A to B one? Yep, if I'm doing A to B, I pulled A from this top triangle, so that's going to be my top. So that means N has to go on top, and G has to go on the bottom. Because N deals with A, really, and G really has to do with B. Any questions on this theorem? Oh, I was going to tell you good news. We don't have any proofs on the test. The hardest thing you have to do is you have to say whether two triangles are similar or not, and why. That's only three properties. That's our angle. Either you prove that two angles are the same, and you can use angle. You can prove all three of the sides are similar, so they have the same proportions. So like 13 over 12 compares to this, compares to that. And the only other one is the side angle side. Yeah.
This theorem doesn't mean that they're congruent or they're similar triangles, right?
It doesn't mean they're similar triangles. No, they're just proportional. This is, why I would use this is in these problems down here. Yeah, it doesn't say that triangles are necessarily similar. It just says that they have the same proportion between those parts, between those exact parts. And in fact, if you look at this, I have a side, but I don't know this angle in here, so I have no proof that they're even similar. I just know they're proportional to each other. If I could prove this angle here, then we could say side angle side, yeah, it works. But we're not trying to do that. We're not trying to prove that they're similar. That was a really good point. I wish someone in the other class would ask that. Yeah, that was a really good question. But yeah, all this is to find missing variables, honestly. Yeah. Thank you for asking that. That was a very good question. All right, so our first one, I'm trying to find A. And we're going to go two different ways to solve this, okay? We're going to go two different ways with this. I'm going to pick the two different ways so that all the classes are the exact same and it matches my notes. All right, so the first way I did 42. The ratio of 42 over 28 is going to equal, so basically I did this length to this one opposite the angle. So it's going to be the same thing as A compared to the 18, that other one that's across from that angle. So that's going to equal A over 18. And then I just simplified it. I simplified 42 over 28 to 3 over 2 equals A over 18. Well, 2 times A is just 2A. Because remember, we're just going to do that cross multiplication, or in other words, that means extremes. All right, so we have 2 times A. That's going to equal 3 times 18. If you're struggling with 3 times 18, just think 3 times 20 is 60. 3 times 2 is 6, so it's 60 minus 6, so it should give you 54. And if I divide both sides by 2, I'm going to come up with A equals 27. It's always nice when it's a whole number because it feels like you did it right. Anytime it comes with like a crazy decimal, it always feels like, maybe?
I don't know why, but you always pick like the proportion that I don't.
That I don't. That's fine.
Like when it was like small to big, you always do small to big, and I did big to small. And this time, I like decided I'd switch to small to big, and you picked big.
Big to small. I would say most of the time I use small to big because I like my fractions where I have the small number on top and the big. Because usually when you have a big number on top, you want to simplify. I don't know. For certain, in my mind, I like smaller numbers on top. It makes it feel like a more true fraction. Because otherwise, you can turn it into a mixed fraction, and I hate mixed fractions, and so, yeah. Sorry about that. But you came up with the same answer, though, right?
Yeah.
All right, I did do another way. I also did 42 over A, and if I'm doing 42 over A, what's that going to be equal to? What ratio is that equal to? MJ? Were you raising your hand?
27, right?
No, there's no. Oh, no. We're solving something all over again. So I'm pretending like I didn't even do this. I'm showing you there's another way to solve this one. And so I have the ratio 42 over A. Who knows what that's going to set equal to if I do 42 over A? You want to take another shot at it? 28 over 18. There you go. I just want to say it's pretty funny because you raise your hand and as soon as the card, you're like, why'd you call on me?
My bad, I didn't know what's wrong.
No, that's fine. All right, so we have 42 over A is going to equal, well, I could put 2 in both these, 14 over 9. Cross multiply, I'm going to have, that is going to equal 14A all over, that's going to equal, I'm just going to look, I don't feel like doing that, is equal to 378. If I divide both sides by 14, my A is going to equal what in this one? 27. Hey, it worked. And Mazen did it a completely different way and it came out as 27 as long as you do it in the proper order. All right, so I think Mazen did 28 over 42 and then just flip these possibly. I don't know.
I did.
Okay. I can't see your sheet. All right, so either way, it comes out A equals 27. So there's multiple ways to do these. All right? So if you're cheating on the test and you see someone else did it differently, don't change your answer. A, don't cheat.
Yeah, I was like,
I'm just saying,
Like darn.
darn. And you erase all your stuff and then you were right the whole time. That's why you don't cheat, because they could be wrong too.
I don't think that's why you don't cheat.
That's the only reason. No, there's a whole plethora of reasons.
One time I caught someone cheating on me, so I changed all my answers to the wrong.
So cheating's bad, first of all. Okay, so we go on to our next one. Well, our next one, we don't know the two individual parts. Here we did. We knew it was 18 and 28. So what I'm going to do, I'm going to make sure I did it the same way in both classes, is I did 40 goes to B. All right, I have 40 going to B, so 24 would go to this section here. Right? So I have 40 and 24 goes to that missing section here. What is this length here? What is that length there? Isabel? 36 minus B, yeah. So that length right there is 36 minus B. So it's just going to be a crazy large number of events are going to happen here because we're going to do our cross multiplication and we're going to see that we're going to have 24B equals 40 times 36 minus b. Well, that's going to give me 24b equals 1440? Is it 1440? Someone with a calculator, please confirm or deny it's 40.
120 plus.
It's 40 times 36.
40 times 36. 1440.
1440, okay. Minus 40. We add 40 to both sides and we come with 64, bravo, equals 1440. We divide both sides by 64 and b equals
22.5.
22.5.
That's the worst, because I thought I got it wrong.
Oh,
So you get like 1440 and then like divided by 64.
and it should, you think it should come out to like a nice number? No, I hate the ones that are like repeating decimals, like it's like 22.56334 1, and I'm just like, well, I can't be right.
Like 5 1/3 is fine, but when it's like